Hey guys, I was just scrolling around and I saw this. Lies. Okay.
The professor's complete and utter hacks. Today, I start my quest to expose their lies.
Let me do something, guys.
Hello, Internet. Welcome to Game Theory, the show whose primary strategy is flail. You know, try as I might, I openly admit that I occasionally get things wrong on this channel. When you've done nearly 200 episodes covering topics as diverse as helicopter physics to gemology and ancient history to hacking, then you fuse those with franchises that have lasted literal decades with each installment involving 60 plus hours of gameplay per game, and do that weekly to meet the unforgiving treadmill of YouTube, well, things unfortunately slip through the cracks. Hashtag excuses. But you know what? At the very least, I have a better track than the Pokedex. Oh yeah! I am calling you out, you septile-spewing Siri wannabe. My eyes were open during my last Pokemon episode where we discovered that the Pokedex was just outright wrong about Charmander's tail flame. And the more I looked into the Dex's entries, the more this realization started to hit. That the Pokedex, this pocket encyclopedia educating young trainers, this storehouse of information that people take as fact, is passing off legends and myths as hard facts at best and peddling in outright lies at absolute worst. And while that might not seem like a big deal, remember, this is one of the primary information about these creatures is handed down. And who's out there correcting it? Not the professors, since as we know, it's frickin' written by them. Imagine if Wikipedia was just filled with lies. You'd never know, and the false information would perpetuate, virtually becoming fact. So like my ongoing series on the psychology of the Marioverse, today I'm starting a new series, Debunk, where I deconstruct the science of the Pokedex one Garbodor fire entry at a time. Because darn it, the 10-year-old Johtoans need to hear the truth that is full of lies. Today I'm starting my one-man quest to debunk Generation. I haven't covered all that much in other theories. Sure, we've done plenty of Gen 1 and Gen 2, even some Black, White, and XY, but I've never really talked about Gen 3, Ruby and Sapphire. The Mon on my mind specifically, though, is Gardevoir, the Embrace. Embrace? Really, Game Freak? What? Like, it gives hugs or something? You can't just throw words out there and expect them to mean something. That's what got you into this mess to begin with. Anyway, here's Sir Hugsalot's Pokedex entry from Sapphire. Gardevoir has the psychokinetic power to distort the dimensions and create a small black hole. This Pokemon will try to protect its trainer even at the risk of its own life. And in black and white, the Pokedex says this: to protect its trainer, it will expend all its psychic power to create a small black hole. So these entries seem pretty consistent about two. Gardevoir has protective instincts and looks out for its trainer, and two, Gardevoir has the power to create small black holes. And I'll give Gardevoir a pass on the first point. I mean, apparently it's the Embrace Pokemon, so it's giving away more free hugs than Cheddar Wisconsin cheese barn. But making black holes out of thin air? Really? I don't think that word means what you think it means, Game Freak. So let's ask the question, what would it mean for our little psychic fairy friend over here to create a small black hole? Well, to tackle that, we first have to ask, what is a black hole? Well, the official definition of a black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape. Hence, well, except once again, we're being lied to by. This time it isn't even by a professor with a tree name. Black holes aren't black. They're invisible. I mean, think about it. It makes logical sense. Your eyes see things when light bounces off them. But if black holes suck in the light, nothing bounces back for our eyes to see, making black holes actually invisible. So black holes are actually invisible. That's a reassuring thought. But we know they exist because we can observe them. Be pulling in other space objects. Black holes have their own gravity, just like planets do. And much in the same way that anyone who trips is immediately pulled towards the Earth by the force of gravity, anything that gets close to a black hole is pulled toward its center. The difference here, though, is that when your feet hit upon the surface of the Earth, you're gonna stop moving. Whereas anything that gets pulled towards the center of a black hole, cross an event horizon, or cross the boundary past which it becomes impossible to escape from the black hole's gravity, and thus by the forces of gravity into super dense matter in the process. It's kinda like the genie from Aladdin.
Phenomenal cosmic power!
So how is Babby black holes formed? The black holes that we're able to observe in space usually come about when an aging star collapses and goes supernova. And I'm not talking about imitation of a supernova. I'm talking about something really tremendously massive getting crumpled down into a tiny space. And when I say massive, I mean really massive. I'm talking 20 times the mass of our own sun massive. But why does that all cause a black hole? Well, we know that matter can't be created or destroyed. This principle of the derived from the first law of thermodynamics and Einstein's energy mass equivalence, E equals mc squared. But all of that is too complex and too nerdy to talk about here, so think about it this way. It's like crushing a bag of potato chips. Even if you completely crush that bag into a teeny tiny space and reduce it to a lump of crumbs, you're not gonna change how much it weighs or how many calories are in it. There's still the same amount of chip in there, it's just sad crushed up chip that you can no longer dip. So now imagine your potato chip bag is filled with the amount of stuff in a star, and then you crumple it down. Well, that's gonna be one incredibly dense potato chip bag, meaning that it's gonna be creating huge amounts of gravity. So on its surface, the claim that Gardevoir can create a black hole seems a bit unbelievable. I mean, sure, it might be good at embracing, but it's not embracing matter 20 times the mass of the sun to protect its trainer. That would be one enormous group hug. But a cosmic event like a star going supernova isn't the only way to form a black hole. There's more than one way to skin a skitty after all. Mostly empty space, with a few tiny subatomic particles making them up. So the recipe for a small black hole is a lot like the recipe for guacamole. Take a bunch of avocados, or in this case, subatomic particles, I personally and you mash them together until they form a teeny tiny microscopic paste. Voila! You've got yourself a mini black hole. And a delicious dip for all those chips you smashed earlier. Can you tell that I'm hungry as I write this script? Where can I work Diet Coke into this? Thing is actually happening on Earth. You may have heard of the Large Hadron Collider created in 2009, which was created for the purpose of particles together at incredibly fast speeds to see what happens, cause science! Seriously, it's like a toddler smacking trucks together, except these are highly trained scientists doing it in a lab that costs $1 billion a year to run. The scientists at CERN who run the Large Hadron Collider are mostly interested in observing new particles, and under the right conditions, they've confirmed that these particle collisions could form a black hole. To quote the official CERN website, another way of revealing extra dimensions would be through the production of microscopic black holes. What exactly we would detect would depend on the number of extra dimensions, the mass of the black hole, the size of the dimensions, and the energy at which the black hole occurs. End quote. Let me translate that for you. They are literally trying to create black holes on Earth. It's wild, right? So based on our current understanding, if Gardevoir can indeed mash subatomic particles together like the Large Hadron Collider, it should be able to make a black hole. Well, at least in scientific theory. So is the Pokedex right? Can Gardevoir actually make a tiny black hole to protect its trainer? Well, if the PewDiePie drama earlier this year didn't convince you that context is important, here's a lesson in why context. Keep reading that CERN article. The very next sentence that I haven't read yet is this. Quote, if particles do appear in the collisions created by the LHC, they would disintegrate rapidly in around 10 to the negative 27th seconds. Wait, what? Disintegrate? Why? Well, remember, matter doesn't come out of nowhere. Much mass is the building blocks that you use to make it. If you make it by mashing together two protons, well then congratulations, you've made a black hole, but it's a black hole with the mass of two subatomic particles, lighter than even a single atom, and completely microscopic. And this becomes a problem for Gardevoir because of something known as Hawking radiation. Now, this idea could get really complicated, but the simple way of putting it is that Stephen Hawking, the famous physicist, proved that black holes emit radiation has mass. That means that as a black hole emits radiation, it loses mass. It gets smaller. It's like what happens to water on a hot day. Over time, the water will evaporate until there's nothing left. In fact, this whole process is officially called black hole evaporation. Usually, this doesn't cause black holes to completely evaporate because most black holes are so large and gain mass from all the matter that they evaporating a black hole in space is more like trying to evaporate an ocean. It just ain't gonna happen. I mean, sure, water is constantly evaporating from the ocean, but more water is constantly being added to the ocean via rainfall and rivers on land. Same thing with black holes. It's constantly evaporating away thanks to the radiation, but it's also sucking in new material, new matter to help it keep growing. But things start to get tougher when we have our small microscopic black holes. Because it's so small, evaporating a microscopic black hole is more like evaporating a single drop of water. In fact, a microscopic black hole would evaporate so quickly that we'd only be able to observe it for like a fraction of a second. I gotta admit, when I first read about scientists creating black holes, I was like, you idiots, you're gonna kill us all. But this fact that many black holes evaporate made me feel a lot better. In fact, in order for a black hole to be stable, it would have to be about the same mass as the moon. The moon! And if that sounds like it's a lot, well, that's because it is. Or at least, it would be a lot of mass. But remember, black holes are incredibly dense, so all of that mass would actually be packed into a really tiny space. Get this, a black hole with the mass of the moon would still be microscopic. You still wouldn't be able to see it with your eyes. Well, you wouldn't anyway because they're invisible, which I already covered and all that, but black holes are so complicated. So enough science, back to Gardevoir. What we've just proven is that sure, it could create a really small black hole, but that's not going to do anything to protect its trainer. It'll evaporate in a fraction of a second. It is useless. On the other end, in order to create something that could possibly even remotely help its trainer, it needs to find a nearby moon and squish it down until it's microscopic, making it dense enough to form a black hole. But even this poses a problem. What Gardevoir would have created is a super heavy microscopic marble that weighs 7.35 times 10 to the 22nd kilograms, or 16.2 times 10 to the 22nd pounds. It's the weight of the moon, but squeezed down a whole lot. Imagine what would happen if you had a pebble that weighed 73,000 billion pounds. Well, for one thing, it would still be affected by Earth's gravity and it would drop like a brick. Except, unlike a brick, it would drop when it hit the ground. Remember how black holes devour everything that's close enough to cross their event horizon? Well, as soon as it hit the ground, the black hole would start eating the dirt, sand, rock, and anything else it touched as it continued to accelerate towards the Earth's center of gravity, gaining mass as it went like a snowball rolling down the hill. It would eventually reach the center of the planet, continuing to eat everything in its path and just getting more and more massive as it consumed more and more of the Earth with it. So I bet you're thinking, oh, I know how this ends. Once the Earth starts getting sucked into the black hole, there's no stopping it, and eventually the entire planet and everything in it gets sucked whole. Well, hate to say it, but that's where you're wrong, kiddo. The Earth would be destroyed much sooner than that. According to Frank Hyde,